I'm Cynthia Madden-Leitner, the President and Director of the Museum of Outdoor Arts. So glad to have all of you here today for the opening of Element House. And it's my pleasure to introduce Michael Meredith and Hilary Sample, the two principal architects of MOS. And they're going to talk about our exhibition today. So thanks again.
Try to sit together to share the microphone here.
Hopefully everyone can hear us. Yes, okay, great. Well, thank you so much. First, we wanted to start by thanking the Museum of Outdoor Arts and thanking Cynthia for this fantastic opportunity to work with the museum in designing this project. And it's really been a remarkable process. We've worked now on the project for about a year. And it's truly a very unique and amazing opportunity in that being young architects at the beginning, more or less, of our careers, having the chance to work very closely with a client who's very interested in architecture, in the arts, in issues of sustainability, ideas of new ways of living. It's been a really remarkable experience for us, and we're thrilled to be here today and working with Cynthia and Sky and Tatum, Kelly, Tim, everyone helping also to just facilitate and setting up the exhibition. We're incredibly thankful for that opportunity. Do you want to?
We're saying this project really is a collaborative project with the museum. I mean, we could say like any time you're an architect, you're working with other people. It's always a very social process. And I can think of meetings where we were sitting down, and the thing that's great about working with a modular design is everybody can sort of play with it. It's like Legos or something. And Cynthia and Sky and Blair, and we're all moving the blocks around, and Kelly, just to look at the design together. And I would say it's as much we're presenting this as much a process as it is a thing. Let's say we don't really see it as there's a final product that's produced in the end of this. That's why you'll see many different forms almost, or shapes of the house itself. So let's get into it, I guess. So when we were approached by Museum of Outdoor Arts, really the mandate was there were a few different things that were important when thinking about a house. I think one of the concerns was to really think about new ways of living, smaller scale houses, let's say, than what is considered a contemporary normal house. Something that's sustainable, something that is modular and prefab, something that can be customizable and grow with individual users.
I think also one thing, the idea of the size of the house and dealing with the module, I think we've seen in the U.S. in the last 10 years a real sort of new model for living, which has been incredibly large-scale homes, ranging from a kind of average house from, let's say, the 1950s being about 850 square feet to homes in the late 1990s and early noughties being something more like 5,000 to 6,000 square feet and up. So the idea that we would look at a house now and rethink about the size and its relationship to not only sort of domestic ways of living, but also those issues of energy that everyone now is very much concerned about. So this house that we've designed is about anywhere from, say, 1,000 to 1,500 when put together in the models you'll see in the museum. But the module allows for that size to change and be adapted.
So when you're looking at these drawings, these are drawings that we've worked with in the computer here. And the module, we worked on a couple different modules even at the core. One is a kind of module that is a more triangular shaped, and another one which is more rectangular in a basic sense. So this one is what we were calling Element House 2. Is one of the iterations or versions of the house with the triangular module. And you can see that the thing that was important is that with the module is to produce these, one is to be able to produce many different room types and sort of a close relationship with nature. So these are relatively small spaces, which are really connected to an outdoor, and at the same time have what we were looking at as passive stack effect chimney systems. So, and it's very well super insulated. I mean, we were looking at SIP systems, which are essentially a foam panel. So these are all basically foam and between two pieces of sheathing of OSB board, which we were working with a manufacturer who was a sustainable prefab modular manufacturer, and looking at these kind of thick walls where we could get a very high R value. So like in a passive home scenario, you typically want about 500 square feet per person. And so we're looking at bedrooms of about for 3 people, and this is about a 1,500 square foot house.
I think one of the things also to look at with the house as part of the module, we looked at other, let's say, types of American homes. We're very interested in our practice in general in the idea of typology and different types and vernacular type. And so these units themselves, when Michael talks about the idea of a kind of solar chimney, the actual sort of tower parts, if you go forward.
The things that look like chimneys.
Yeah, the things that look like chimneys. So
Yeah.
sort of the evolution of how a chimney evolves throughout, let's say, the development of the American home, but also to things like porches and a kind of large scale, let's say, picture window even. So these sort of, that's part of, I guess, the way the name of the house evolved, not just through this idea of a kind of unit of the house, the Fibonacci, but actually through this kind of a sort of tracing through, let's say, history of how the hearth shifts through different types, from Frank Lloyd Wright, Gottfried Semper, Louis
Yeah.
Kahn.
So,
talking about that.
I mean, there was a sense that let's say at one point the hearth was I mean, for a lot of people have sort of talked about this, the hearth as the kind of center of a home, and they were really the center architecturally too. They were the anchor structurally for a house in which you would deal with. And then at a certain point nowadays with houses, the chimney as a structural anchor for sure is no longer the case in most vernacular houses, let's say, or development houses, like it was once. And so we were looking at this idea of what happens if you to rethink the chimney in general, not as a solid masonry unit like it once was to begin with, but as a void. And it works in a similar way to produce, let's say, heating and cooling. In this case, it produces cooling as much as heating for a house. So these were some early studies, let's say, just to go through the slides, and then we can have, it would be nice to have a more general conversation with everybody that's here about the project and questions. Really early, kind of very straightforward things. And these were what we were talking about, like when we came to it, we would sit in the conference room and be playing with the blocks and trying out different ideas and thinking about what a house is and what do you need for a house, what are the rooms, what kind of spaces. We were doing early studies here, which I'm very sorry, it's kind of, I can't even read it. But the
we would yell at our students for presenting something like
but
this.
you get a sense of, this was studies of looking at different programs in Fibonacci series and growth, and that was something also that had come up a lot, is to literally think of growth in a modular system more like nature. If you could get a house to think like nature somehow. These are some models that we did. Most of them are, I think, most everything that we did in the kind of models are in the exhibition.
We were asked to come up with a few different ideas for the house, and so this first one we were calling the Longhouse, which has now become Element House 1, and then the second one, which looks at a more sort of rhizomic branching pattern, which is Element House 2, just so you'll see the difference in the slideshow we show here, but also in the exhibition.
So in this one, the Longhouse, which was sort of looking at, in a way, even longhouses in, let's say, Native American culture, was we were thinking of this where actually all of the storage and the program and everything gets embedded in the sides of the house, so it would become like additional insulation. Let's say it would help to further insulate the house. Your stuff, your clothing, all that stuff could be used in this zone, which could be between, this is a 10 or 12 inch insulated wall, and then you would have further level to help with thermal breaks and also performance. These are the type of drawings we did. We sort of were trying to think of a project where you could imagine it, if you could, like a IKEA or something, where you could get a kit of parts and imagine putting it together easily. So if we could produce a set of instructions that would sort of explain the construction of a house. These were some of the, again, early drawings. You want to talk about it?
Sure. So as part of the idea also to make the house with this idea of units and Fibonacci, in a way, for us, when we design something, the process is very much an iterative process, back and forth, working with many ideas at once. It's definitely not a linear process, doing one thing and then the next thing follows, never to revisit what we had done before. So we're always looking at these things in tandem. And so the issue of sustainability for us really comes into play as one part of the overall design. I wouldn't say that we would design something with only ideas of sustainability and forget about the rest. I think it's important that we look at form as much as we're looking at how it actually functions in the end. So through both of the schemes, we try to look at ways in which the project could itself operate and function through passive means, and that it works as a kind of responsive system to its local site. There was also discussion about that the house would be right now proposed for a site in New Mexico, but that it really could become a model and travel and be located or built in other locations. So that led us to start to think about different ways in which the foundation could work. And we've created, I'm not sure what's next exactly, but a different way in which the house would actually begin to meet the ground. And we've designed a kind of sloping foundation. We've actually built a little mock-up model inside the museum that you can look at that. So, trying to deal with issues of soil conditions, rainwater runoff, rainwater collection. There's an idea that in the base of this foundation we've designed, you could actually have all of the water be contained in a sort of cistern, like collection system at the bottom, and that the solar chimneys then act in a way to draw cool air that's been contained in the house, let's say during the day. Ideas of working like solid mass. So to work more passively, almost in the way, specifically when looking at the New Mexico site, drawing on references from the Kiva to Pueblos. Again, these ideas of tangentially looking at type and the way, not only formally, but also in terms of performance.
I would say also we worked very closely, we should talk about Atelier 10 a little bit, worked very closely with climate engineers. We're, in the end, still architects and not engineers. And so we were working with this group called Atelier 10, who was incredibly great to work with. They did a lot of modeling for performance for the house to look at how it functions. They were located in New York, and they were actually pretty instrumental. These are some sort of images of us. There's sort of a kid waiting for her, I don't know, carrots, and a little dog here that's sort of sleeping. Sort of looking at imagining the life of this house a little bit in the section here. Like, what would it feel like to live in it? And I think that's something we always think about when designing as well, is try to imagine being in it and imagine what life is like inside of these things. These are some earlier models that are a little crazy.
Variations or hybrids. We also are really interested in this idea of how houses typically in the middle, I mean, especially if you think of a kind of Victorian house, is always super dark in the middle. And so as much as the chimney works to allow air through, it also allows opportunities to have light come down into the kind of center or spaces that typically would be considered a dark zone in a house and require artificial lighting. So we've looked at ways in which light can start to become more dispersed and perhaps more even in some ways, and not rely on a kind of artificial means. So this is a sort of, the kind of Clear Story works. It's operable, can allow for airflow, but it also allows for a kind of diffuse light into the middle. And this is the sort of foundation with the opening that could allow water collection. It's also the place where we're running all of the
Services,
systems,
yeah.
Electrical.
The one thing with the foam walls is it's difficult. I mean, you can do it, but to run all of your electrical and everything in the wall. So we were thinking you would run it in here or in the cabinetry. So there's a lot of cabinetry there, and also the cabinetry works, let's say, structurally to help stiffen the corner, like a gusset plate or something like this, to help stiffen the corner for lateral stability and thinking about the moment when you have like large wind loads on the side. These are some more studies and looking at different ideas of growth, and these were kind of early on, different forms that were kind of more, maybe more natural forms in a certain way. Similar. Some study models. We're kind of going backwards now in time a little bit to the beginning. Should we be saying something about these?
We'll just keep going, I think. It's a
I
little
feel
slow.
like we're just going through it. Some just crazy.
I think the ideas here were about kind of aggregation and when they could come together to create actual larger communities. So you could imagine having multiple sort of families, neighbors, and then creating different outside spaces in between the houses. So it's a... And the idea also that it could become a very smaller than even 1,500 square feet, let's say, where there's only a few units put together, and that then it aggregates and could grow to become a kind of larger house to accommodate, maybe an extended family or something.
Yeah, we were
like
thinking
this.
like if you had, I mean, one of the bigger problems always is in, let's say buying a home, is that it's hard to imagine adding on. You buy it at a time when if you didn't have very much money, you could just buy. Everyone could live in a kitchen for a little while, and then continue to grow and add on to it, and start to then get a bedroom eventually, bathroom maybe. So it was an idea of if you could think about a house that could literally grow and think about it adding on to itself. I don't know. I mean, I think we would really be happy to hear and talk with the audience a little bit and get some questions and feedback, because I think for us it could be interesting to hear what other people think and questions, and try to open it up to a conversation. There's so many people here, it seems like.
That's great. Keep going. Just...
Yeah, do you
Okay.
want a mic?
You keep it. Well, we have the foundation. The question was, how do we keep it from blowing away? So the foundation, in the way it works, it would be all concrete, but we also have points where it would attach and have grounding into the soil as well. So the idea is that this could be a piece that would be potentially either prefabbed and arrive on site, and then it anchored and attached to another sort of foundation in the ground, which could be as simple as something from sonotubes, a very sort of basic structure, to other ideas. It would depend upon the soil conditions also, so that's something we have to work with a soil engineer in order to actually figure that out.
Yeah, usually when you start this is different than a typical architecture project, let's say, house project. Usually one of the first things you do whenever you start a house is that you have a soil engineer go to the site, and they'll tell you, they'll test it, and they'll say, listen, you need a spread footing that's so large and it needs to be this deep. And we really started without a really specific site, a more general site. And so the question of the earth was always something we were trying to think about. Could we think of foundations in a new way? And we're trying to think of them as like caissons more, like if you can, like you could sort of float a lot of the foundation above the ground, which is kind of typical in a sort of a slab foundations are one type, and then anchoring it into the, like Hillary was saying, downlaying it or with screw anchors into the ground so it won't blow away.
Mm-hmm. I think just
also the lateral, sorry. We do think about this a lot, so you're bringing up, this is right, this is why we like questions, is that the geometry itself also helps stabilize it from wind loading. So when you have like this kind of angles, like kind of pushing in at each other, you don't have like a large, this was one of the benefits of, let's say, the second version versus the first version. When you have a large flat plane and there's all this wind blowing on it, it creates quite a load, and it wants to, you have to do more to the earth to avoid tipping over. When you had all the smaller pieces and they're all kind of pushing against each other, it helps to reinforce and strengthen it in a kind of lateral load.
Mm-hmm. I think also it's a really good question because issues of soil is something that, I mean, as architects generally, you don't really get involved with that. That has to do with the engineer, but there have been a lot of reports recently in various newspapers talking about, especially this past year, the kind of amount of rainfall, let's say, that's been happening in the U.S., and a lot of people now are starting to see this kind of heavy downpour and then, sort of rapid evaporation, and the change in soil around foundations has recently, it's a kind of strange phenomenon in a way, and what's happening are a lot of people's basements are becoming cracked. And so as a homeowner, you buy a new house or you build a new house, especially in a lot of these suburban developments, and in 5 years, all of a sudden your basement is cracking. And
your structure is horrible.
Yeah, it's become a huge issue. So it's something that this project gave us an opportunity to start to think about ways in which we could rethink how foundations perhaps are made. And it's a big task. It's probably more something related to engineering, but we felt that it could be something new for the form of the house that we could begin to look at, and seemed like a very exciting opportunity to start to look at that.
Think about sound and how sound would travel throughout the house.
So the question is about sound, and did we think about that and how it would travel through the house? Do you want to answer that?
Sure. I mean, the one thing from other projects that we've done, I would say the walls and material become really important, and we really haven't figured out, to be honest, all of the material. It's hard to do it without a real person that's going to use it, But the form, I mean, we have been thinking about like how noise would travel, and there are still rooms. It looks like where the bedroom is, there's still a bedroom. We should go back to the kind of plans, I guess. And where the bathroom is, there's still a bathroom. So you don't. Those are insulated and made out of SIP panels as well. Ooh, we're going to a different project somehow. Sorry about that. I hit the wrong button. Went the wrong way. One more.
Yeah.
So you can see here, so let's say it is generally a very open plan, except for those areas where you would want more privacy. So a bedroom, this bedroom, which I think would be a pretty awesome bedroom to be in, to wake up and have nature on both sides of you, is separated from, let's say, general living. And the bathroom is separated from this. And so you do have a kind of a separation of, let's say, things where you don't want to hear people in the bathroom from the general living, and you want to be able to sleep and still have people, maybe having, if you had guests over and somebody wanted to go to bed, you could still go to sleep. But the specifics of it, a lot of it would require, with acoustic engineering, a lot of it is materials, it's the rugs, it's softer materials. It's how you deal with the window treatments if there's a shade which is very much individual thing.
Yes.
The pictures look like a brick facade, which I'm sure it's not.
No.
What is your structure for
Right.
The cladding, I think you're talking about the cladding a little bit. We looked at a bunch of different things, and I could honestly say it's still, I just talked to Sky, and he was saying that the steel seems to be the more popular thought right now than the aluminum because it's more sturdy. But we were looking at one point, let's say shingling systems, because then with shingles you can think very locally, let's say in terms of material. Just shingle as a technique, let's say. This is looking at a cedar shingle here. We were looking at aluminum shingles. We were looking at steel shingles. And, you know, and at the same time when we're doing this, we were acting as, even though we're not, like a kind of contractor. One of the other goals that we didn't really get into is how to make this incredibly affordable in a certain level. So it could deal with a kind of a general audience. And we were trying to get things down to, we're not professional estimators for sure, but trying to get costs down to close to $100 or $120 a square foot for materials and not labor. We didn't know how to calculate labor. Or it was around actually it was around $100 a square foot for materials. And labor we tried some of it, we tried figuring out some of it in terms of we can get the labor for the modules and all the big pieces, the prefab pieces, which is part of the labor, but not for it. So the numbers are kind of nuanced. When I throw out that number, there's actually more involved in it than just a material cost. So this was looking at cedar shingles, but aluminum is an option, steel is an option, other materials for shingles, we would be open. It's just a technique, and for thinking about the sort of facade, and it's a way that also, frankly, it's kind of a known way to make elevations and facades. So it's something that is a really known, tried and true kind of vernacular technique that we can really study and look at and figure out how to apply it in different sites. So, does that make sense? Yeah.
So is it assumed these people take the bus or park their car outside? Or is there-
No, that's a good. That's a good question.
Is there a lot of people around?
You're right. No, we do have a garage. The idea for the garage, which we don't show here, is it would be solar panel system, and then you park. It'd be like a carport. So you'd have like solar panels. It's true, actually. We didn't show that. You know, this is so pristine and ideally. What would be the ideal mode of transportation? I'm trying to think.
I think that's it.
And yeah, it's like solar panel levitating machine. I don't know. Yes. Yeah.
I have a question about the height of the chimneys. Must they be that overwhelmingly large for this house?
That's a good question. I think we like them being, let's say, spatial, and they probably could be smaller. I mean, things could shorter. You mean? Oh, tall. Oh, the height. No, the height is important. I mean, the height is probably you want to get it higher up, like any chimney. Chimneys work by being high up because you have a higher pressure at the top, let's say, than at the bottom. And so the higher it is, the one thing that this thing does, they do need to be high. You can't it's hard to have a short chimney that works really well without additional airflow. So you want to produce what they call stack effect or the chimney effect. So you get like air moves faster up above, higher up. It helps draw the air out from below. So the higher up you go, and then in a way the better, because it's the higher differential between the two areas. And then the other thing that these things do, which is why we wanted to keep it up, is with the glass here. The glass is on the south side of the chimney, so it actually gets hot here, and the higher it is, it keeps. So if you keep the window shut, you create a kind of warm air mass, so that in the winter time it starts to help, let's say, keep a kind of constant temperature, because this is a hot air zone in here. And in the summertime, the hot air, which would be hot air, you keep it open, and it helps induce also the breeze and the passive cooling So we wanted you need some height to do that. In fact, they're I thought they looked kind of stubby. You think they're tall? I don't know. Yeah.
You mentioned the Fibonacci sequence in the development of the project. Was that a determinant or was that a result of discovery? And I'd also like to ask you to speak to the shape of the modules and how the angles were determined.
Okay. Which was the first one? I got the module. This first question was Fibonacci. Oh, the Fibonacci was it predetermined? In a way, yes. That's a simple answer. It was a kind of idea of thinking about growth, and it was something that Cynthia we had discussed early on, and it was important to try to think of a house with natural systems in a way. And the second, the triangle. I mean, we did look at lots of different triangles, and the one we settled on was after a series of processes of working with the fabricator who makes them, what angles we can cut at, because they do oblique cuts. They have to do oblique cuts to put the panels together and stuff like that. So there's a range of angles that you can do. There's there were certain geometries we were looking. Also, I would say we were interested in some of these Frank Lloyd Wright houses that were done late in his career. These hexagonal houses. I don't know if you know those or not, but which we thought were also good. So there was a series of. I wish there was one easy answer to that, but it's not. It's a series of decisions in a process that eventually you arrive at this kind of angle. It's not like we say, "Oh, that's great." We have to talk to a lot of people. We talk to the manufacturers. We make sure this works. This works. They come back and say, so it's a kind of a process to get there of kind of looking at many things. And we did try other shapes, some that we won't show you because they were kind of really bad ideas. But we did try other things out and finally arrived at this angle. Yeah.
So you're talking about, like, for the prefab, what would be like the price estimate since you're shingling 3 times the amount now?
Well, the cost per square foot of the SIPs. Well, there's a couple things. This helps us with, let's say, the surface area is one thing because we increase surface areas, right? But we do get a couple other benefits. One is we get a lot better passive daylighting because it's more open. You get better passive cooling because it's also more open and better connection to the outdoors. The shingles themselves, it's a labor cost, but if you can make a shingling system that isn't like the cost per square foot for, I'd say a shingle, like a cedar shingle was $6 a square foot. For aluminum shingle is like $1.75 a shingle. We went through all these studies on actually the cost of them to figure out how to make it feasible within it. The SIPs themselves are something like $5. Is it $5 a square foot for the actual panel? Is a kind of
Right. Well, I was just thinking that because of shingle replacement, because of like how you're saying the angles change and deflect the air. But I was kind of thinking that with the negative shape, it's also going to create.
yeah, but if you have, you're right. It would create an eddy kind of uplift. Yeah.
So I was thinking with the regular shingles or the cedar shingles, you have to replace way more often.
Yeah. No, we did. I mean, we're
25
more
years or
metal.
something. Yeah.
We went in the end. I would say metal. This like the image with the cedar is still from an earlier scheme. In the end, we went with aluminum, and then even further in the end, maybe steel, because this is something that's more sturdy. Shingles, we found this really awesome guy in Oregon, actually. He's like, really, the internet's pretty amazing. You can find all these people. Yeah. Yeah.
We have time for one more question, and then we have a reception that's, please come in and see the show and the exhibition. You can ask Michael and Hillary some questions. We also have a catalog inside the museum that talks extensively about this project that Michael put together. I just wanted to say, there wasn't one question that wasn't asked that I sort of anticipated is why would an outdoor museum why would an outdoor museum have a show like this, and why would we connect with an architectural firm like MOS to have a show. And the intent, over the past maybe 10 or 15 years, the intent of this museum is always to be a catalyst to change and growth. And we've always been totally immersed and fascinated by how art, when it's composed, your response to it as a human and what that's called. And it's usually a reflection of nature called sacred geometry. And architecture, always the belief we've held is in sculpture, architecture, art, that form is function. They aren't separate. And I was introduced to Michael, I don't know, it seems like a couple years ago, studied what Michael and Hillary had done, knew how progressive they were with the whole sustainability movement, the whole idea of being off the grid. It occurred to us at the Museum of Outdoor Arts, what does outdoor arts mean? And as we move forward with the museum, outdoor arts means architecture also, but it also, art and architecture do not have to be mutually exclusive. And what we're accomplishing here through what their design reflects is that it's an artistic statement that's functional, of course, but also it also contributes to sustainability. It contributes to the consciousness of what's going on in this country about new ways of living. So from that standpoint, we're extremely excited that they've worked with us on this project, and our goal is to next year build a prototype. And you can read a little bit more about that inside the museum. But one more question, and then when you leave the room, we have a short survey on sustainability. You can take it into the museum and fill it out there, but we'd really like you to put check marks down. And our deal was that you could take it up to the bar and get a drink for free, but you can get a drink for free anyway. But please fill it out for us. Thank you for coming. One more question.
You can see why we had such a good time working with them in a way. Is there one last question? Yeah.
You thought about disassembly and possibilities if one of your units are set up that more disassembled and new?
Yeah, that's a good question. I would say the foundation problem is really one of those things that Hillary was talking about. That was one of the reasons for thinking about this also. Is like if you had it with a precast concrete unit or something like this, and you could have screw piles, then you could figure out how to move it. I would say we haven't really gone as far into that issue as much as I think would be interesting, but we've started to think about it through the foundation. I think that would be a whole other set of problems to think about that I can't, I mean, I can, it's a really interesting provocation.
Yeah.
So, I mean, we'd like to go into that more.
I think also, maybe on a slightly different note, this past year and a half for architects has been so depressing, and that the idea of we just want to see something built, so
Yeah.
we haven't really started thinking about taking things apart. But
Yes,
that's a great question. We also, just one last thing, would like to really thank everyone in our office. We didn't build these things by ourselves. We
Yeah.
had Jason, Gab, Gideon, Ryan,
Michael.
and Kira, Elijah, and Marika, who all helped us with the project. So thank you so much.
Thank you.